Hi, I'm Abhimanyu. I'm founder of Koala Lab, and just like SafeDep earlier, we're also a software supply chain security company. But rather than securing the open source libraries, we actually focus upon the software development lifecycle infra. So basically everything from your GitHub to your CI/CD to your code pipelines, that's what we try to secure. And I think today I want to talk about CI/CD pipelines. Basically, our whole thesis is that we want to make the SDLC secure by design. Application security has been a problem for everyone who's here, who's been in the security industry, because you need to liaison with the engineering teams. And I think getting them to focus upon security has been a bit of a problem. So our whole endeavor is to make your software development infra secure by design so that a lot of the work around AppSec actually reduces. And today I want to talk about securing your CI/CD pipelines. So specifically talking about, CI pipelines, we for a developer, CI pipeline is where they come and, deploy build their code. But for security folks, CI pipeline is where the security orchestration center of the SDLC is. I mean, at the end of the day, all your SaaS scans, any kind of license checks, all the scans actually happen in the CI pipeline. But the reality is these pipelines themselves have become the new attack surface. Most of us today still have been putting security in the CI. Today, I want to talk about the fact securing that CI. And I think the reason for that is in the last 3 to 4 years, SolarWinds, CodeCove, few of the high-profile attacks that have happened, even the malicious cyber actors are focusing upon the CI pipelines. They are the gateway to your cloud kingdom, and they are high-leverage, attack surfaces. So there is no wonder that these guys are trying to attack your CI pipelines. And the other reality is that security of CI is complex. Now, all of those who've been in the tech world today know that there is a true shift left that has happened. Almost all of the developers today are involved in your DevSecOps operations. They actually do go and build their own codes. They write their own workflows. And as I mentioned earlier, developers, for them, security is an afterthought. So this is one of the complexities that has come up because of which the attack surface has increased. The other fact is that although, as Abhishek previously also mentioned, that OSS dependencies are part of your SDLC, but the other reality is that even the workflow code, which you write to build your code, that itself has now third-party code. So GitHub Actions has some 23,000 plus actions on their marketplace. Circle CI has some 3,500 orbs. And even Jenkins, if I remember correctly, probably has some 1,900 plus plugins. So because of all of this, even the security of your CI has become complex. So this is broadly a chart which, talks about the threat vectors in your whole software development pipeline. I want to focus upon the CI runtime or your build time, and these two specific threat vectors that we have, which is secret exfiltration and build tampering. So I think before I get into that, you need to understand the nature of CI. CI is a traffic source because at the end of the day, it is calling a lot of dependencies, these dependencies and actions during that time. And the other thing it does is, after the code is built, it actually sends the code to your artifact libraries or artifact storage. So it's a CI, it's a traffic source. And this is effectively what happened in the COV breach, that attackers were able to get access to the CI/CD of CodeCove. And what happened was, this specific last line, they were able to change the IP from CodeCove IP to their own IP, which was some, let's say, quote-unquote Russian IP. And they were able to exfiltrate all of the GitHub environment secrets to that server of their own. And because of that, they were able to, get access to CodeCove's whole cloud system and breach it even further. So data exfiltration in the guise of an API call, that's what happened. And all the build environment secrets got leaked. So specifically talking about these two, threat vectors, the secret exfiltration and build tampering. For this talk, I will just focus upon secret exfiltration. Build tampering, if Accel has another security event, maybe I'll talk about that later. But specifically about secret exfiltration, I think this is where understanding from runtime security or from cloud security comes in. What do you do? Like if there is some data which is going out from your traffic source and you need to secure it, it's very simple, right? You call Palo Alto and you put their network firewall. I think specifically here, we don't really need to go that deep. Since CI is just a traffic source, you just need a egress filter on top of it. And I want to do a deep dive on what kind of egress filtering or very lightweight egress filter that you can build. So let's say you do want to secure your traffic from going out of your CI, and there are only certain domains or certain IPs that you want to restrict your traffic to. So one of the things that you do realize today is that IP-based rules do not usually work. Almost all of the domains today are behind a CDN like Cloudflare. So one IP serves many, many different domains. Like even our own website, koalalab.com, is on wix.com. So that one specific IP will have domains of a lot of different other companies as well. So just doing an IP-based ruling, that will not work. What does work is host filtering using TLS interception. So effectively what you're doing is, intercept the TLS handshake by a transparent proxy and figure out which domain is the traffic going to. And the way to do it is by actually creating a whitelist of all the domains that your build environment will need and restricting traffic to that with that specific SNI. So we built a product called Bolt, which is open source. I'll link to that at the end of the talk. And as you can see here, this is just an example. We wanted to create some egress rules. For example, we want to block google.com and we want to allow ifconfig.me. And you can see here in the enforcement that google.com has been blocked. But I think that's not the only thing that you need to do. We also have some github.com domains that are definitely required for a build environment to work upon. And those have been automatically whitelisted. So we maintain this whitelist of domains that will be required for a build environment. This is a default policy that we have. You can run Bolt or Bolt's egress filtering in either audit mode or in enforcement mode. For example, this is being audited right now, so we are just checking what all traffic is outgoing. And actually, if you run it in enforcement mode, all of this traffic will be blocked. But the reality is this enough? Is a domain-based filtering enough, or is it not? And here's the thing. At the end of the day, your CI pipeline is talking to a lot of mirrors like GitHub and Docker Hub, which are all multi-tenant in themselves. So your enterprise has a GitHub account. All the open source dependencies that you talk to, they have a GitHub account. Even the attacker has a GitHub account. So because of that, what you specifically need to do is you can't just say, my traffic is going to github.com and it should be allowed. You actually need to go do deep SSL inspection of all the outbound traffic and figure out which sub-account or subdomain of GitHub or subtenant of GitHub it's going to. And same for Docker Hub and a lot of the other mirrors. So when we were encountering this problem, we figured out a solution which was MITM Proxy. Now, usually what happens is MITM Proxy usually has a very bad reputation in the security world. We do believe that it's a very powerful tool. But in this specific case, we were sort of unsuccessful. So MITM's mechanism is that it intercepts your certificate, and it becomes its own certificate authority. So for your host, which will run your build environment in various different stacks, you actually have to create a certificate authority for each of those stacks. For example, in Java, you have to go to key tools and create that in Node.js using Node Extra CA cert, so on and so forth. So what happens is there's a very huge implementation sprawl. So for workflows, which are of various different kinds, you have to implement all of them individually. And one of the problems we encountered was that if these are not configured correctly, your builds tend to fail. So what is the solution here? And just like, the buzzword in security is EBPF, that is the panacea for all the security problems. And even here, that will come to the rescue. So EBPF is a very powerful tool which basically allows you to set up probes in your kernel system as well as your user space. For example, here we have some probes which end up doing SSL write and SSL read in the user space. And I will not go too deep into this, but what we've been able to do is EBPF allows us to capture network packets before they get encrypted and also capture them after they get decrypted. We take these packets and pass them for deep SSL inspection. So every root, for example, for a github.com, there'll be a specific kind of root. For Docker Hub, it will be a different kind of root. You can create root level rules to enforce controls across your tenants. You will be able to do a deep SSL inspection and be able to look at the whole API call that is being made. And so this is what we did. And we were able to implement eBPF in Bolt itself. And what we did was we created another policy in your egress filtering configuration where you can create trusted GitHub accounts. For example, there is a friend of ours and company called Acto. In this configuration, we actually put their account as a trusted GitHub account. And when we actually ran a specific workflow, we were able to see that there were calls going to specific GitHub accounts called Temurin, Razorpay, Teammate, etc. So this is just an example. In this specific example, Temurin and Teammate, although they are not malicious libraries, but you definitely want to see if there is some specific GitHub sub-account which probably an attacker could have set up and whether your traffic is going or not. But at the end of the day, using eBPF, you are able to do deep SSL inspection and also able to figure out which specific subtenant or tenant of GitHub your traffic is going to. And you're able to configure trusted GitHub accounts in your in Bolt itself so that any outbound traffic to non-trusted GitHub accounts can be stopped. So specifically when it comes to eBPF and we want to compare it to MITM, one of the things we realize is that the implementation sprawl here is actually very, very limited because almost all of the libraries that you usually use for your workflows, their TLS their sub-TLS libraries are very limited. It's either libSSL, boring SSL, or for Golang, it is crypto TLS. And implementation of eBPF for libSSL and boring SSL is actually very similar. There's a little bit of implementation problem that happens in crypto TLS for Golang, but it's not that hard to do. There are a lot of sources around the internet which have been working around eBPF, CubeShark, BPF2Go, libcapstone. A lot of these libraries are being used. And the other specific thing that eBPF wins upon is that even if your implementation of the eBPF probes are not correct, the builds do not fail because eBPF itself grows into a graceful failure. Again, there's a lot of nuance to this as well. But I think more or less compared to an MITM proxy, the eBPF implementation is much, much better. So yeah, I think that was the talk I had. I think just as a summary, I started with the fact that securing CI today has become very imperative. Apart from it being the security orchestration center, securing it itself is very important. There are specific threat vectors that you can see: secret exfiltration and file tampering. Going into secret exfiltration, an egress filter or monitoring system definitely need to be set up. And the way to do it is through an eBPF probing, and you can actually do deep SSL inspection and also figure out whether your own GitHub is talking to the GitHub that you want to and not somebody else's GitHub. So yeah, that's me. And these are the links to our domain and the open source version of Bolt there. And it's also time for lunch. So I thank you all so much for coming to my talk. Thank you so much.